Welcome to Study Loop.
Okay, we've got to find out which of these molecules are possibly chiral. So first thing we'll have to do is draw them. Let's do 1,3-dibromopropane. So 1, 2, 3 carbon chain, because it's propane. We've got bromine on carbon 1 and bromine on carbon 2, or carbon 3. Can this be chiral? Well, to be chiral, we're going to need a carbon, which is attached to 4 unique or different substituents. Let's look what this first carbon is attached to. Well, it's got a bond to a bromine up and to the left. It's got a bond to a carbon up and to the right. The other two bonds are both to hydrogen. So this carbon cannot be chiral because it doesn't have 4 bonds to 4 unique substituents. What about carbon 2? Well, carbon 2 also has 2 hydrogens on that carbon, and carbon 3 is exactly the same as carbon 1. So A, not chiral. What about B? Now we've got 2,2-dibromobutane. So that means both bromines are on carbon 2 of the propane. Okay, now we can look at carbon 1 here. Carbon 1 actually has a bond to a carbon and then 3 bonds to hydrogen. Carbon 3 is the same, 3 bonds to hydrogen. If we look at carbon 2, well, we can see right away that we've got 2 bonds to bromine, which means that this cannot be chiral either. Let's move on to C. For C, we have 1,3-dibromobutane. So butane is a 4-carbon chain. 2, 3, 4. We've got a bromine on carbon 1 and a bromine on carbon 3. All right. Well, carbon 1, let's check. It's got a bond to bromine, a bond to carbon, and then 2 bonds to hydrogen. So carbon 1 cannot be chiral. Carbon 2 has 2 bonds to hydrogen. What about carbon 3? Carbon 3's got a bond to a carbon. It's got a bond to a bromine. It's got a hidden bond to a hydrogen. And finally, it's got a bond to carbon. Now, the question is the carbon on the red side the same as the carbon on the blue side? If they are, then it's not chiral. But if the carbons are different, then it will be chiral. So the blue side is a carbon that has 3 hydrogens attached, whereas the red side has 2 hydrogens and a bond to carbon. So you might say the left carbon is C attached to H, H, C, whereas the blue is C attached to H, H, H. And since these are not the same, then that means that this carbon is chiral because it's bonded to 4 different things. Okay, finally, D, 1,4-dibromobutane. So butane, once again, 2, 3, 4. Bromine on 1 and a bromine on carbon 4. Let's take a quick look. We know that this carbon has 2 other hydrogens, so that can't be chiral. 2 hydrogens here, not chiral. 2 hydrogens here, not chiral. And 2 hydrogens here. So D is also not chiral. So the only one of these molecules that is chiral is C.